All right, so we're working on 6.2. This is a sequence of transformations that include dilations. So we're taking everything that we learned from section or unit 4, and we're going to include dilations into it. So if you go back and you remember all those algebraic expressions that we learned in unit 4, we're going to be utilizing those and the algebraic expression that we learned in section 6.1. And our intro to Unit 6 back before Thanksgiving break. And we'll be applying it to transformations. So our goals today is to describe the sequence of transformations that include dilations. We'll actually be showing you those, and then a repeated sequence of transformations using coordinate notation using algebraic descriptions. So we'll be kind of doing that as well. Biggest thing here is I want you guys to learn what if a transformation is cumulative, right? So that means that you can do the transformations in either order and you still end up with the figures in the same spot. The vertices are all in the same spot and everything. Okay, so here we have an original set of, this is going to be our first set of transformations, and our second set of transformations, the only difference being that our dilation is going to be second in our first set, and or in first in our second set. So I'm just going to take this guy here and just swap these two. That's not what I have to do. I'm going to swap these two here. Here, that's our algebraic expression for dilation. And what is this? It's a rotation. You can remember what type of rotation is. It's a 90-degree rotation. You know it's 90-degree rotation because the x's and the y's swapped, and one of them is negative, right? So with the y is negative, you remember that it's a counterclockwise rotation. If the x is negative, it's a clockwise rotation. 90 degrees. 90 degrees. If the x's and the y's didn't swap, but they're both negative, then you know it's a 180-degree rotation. Okay, so let's go ahead and plot this polygon. It's a quadrilateral. It has 4 sides. I'll go ahead and do that and grab this one. So my first image here, or my first Q point, is going to be -1 and 0. So it's going to be right here. That'll be Q, a little flat there, make it a little bit better. I'm going to make that Q. Okay, that's pretty good. And R is going to be -1 and 1. So it'll be -1 and 1. So -1 and 1 is my R. Negative 1 and -1. -1 and -1 is my R. I'm going to zoom in a little bit here to make it easier to do this. There we go. -1 and -1 is my R. And then my next one is -2 and -2. Okay, so I got -2 and -2 is that one. And then my final one is -3 and -1. So -3 and -1. That is my first image. My first pre-image, I guess. My first pre-image, I'll connect the dots like this. And actually this should be like an up and down line. And that should be like that. And this one will be like this. And this one will be like this. And that's my small one. And then I gotta label these things. And I'll label them with a pencil. And this one was QRST in that order, QRST. So I went Q, make these different colors so they pop out. So maybe make it a little fatter. Right, so Q, it's one different color. That different color. Q, R, S, and T. All right, so that is my first quadrilateral. Okay, that is my pre-image. Okay, so my first one, my rotation of QRST, right? I'm gonna make these dots red, right? I guess I'll make them blue. Make them blue so that there's no confusion. Okay, so my is going to be my rotation, my algebraic expression that I'm going to apply to these points. If you, this will be a refresher, right? I'm going to swap the x and the y values. And what before I do that, or after I do that, it doesn't matter. Whatever was my initial y value is going to change sign. Okay, so first thing is I'll just take all my x's and my y's. I'm going to swap them. So my x value, my new x value is the opposite y value. So, well, the opposite of 0 is still 0. The opposite of 1 is negative 1 is 1. The opposite of negative 2 is 2. And the opposite of negative 1 is 1. Okay, and then my new y values is all the old x values. So there's going to be some commas in there, and it's going to be negative 1, negative 1, negative 2, and negative 3. These will be my new points. All my new points for these prime points. Okay, so I'm going to go ahead and grab this. So 0 and negative 1 is going to be my new Q prime point. Okay, so 0 and negative 1. So my 0 point and negative 1 is going to be 0 and negative 1. It's going to be my new Q prime point. Q prime. Q prime. And then my next one is 1 and negative 1 is going to be my R. So it's going to be 1 and negative 1. This guy kind of like counterclockwise. So it's going to be R is 1 and negative 1. I'll go the wrong way. So I've got to grab this one again. It's going to be 1 and negative 1. So this is going to be my new R point. So this is R prime. R prime. Okay, and my S prime. S prime is 2 comma negative 2. So back in and this one back in. It's going to be 2 and negative 2. 2 and negative 2. Tiny little things here. That's going to be my S prime. S prime. And my T prime is going to be 1 and negative 3. 1 and negative 3. 1 and negative 3. 1 negative 3. And it should give me a shape similar to what I had before. I was using skinny line. Skinny line. So it's going to be similar to what I had before, just kind of like rotated. So that is my new rotated point. Kind of like that. Okay. So there is there's that. Okay, so now I'm gonna dilate this. My next one is gonna be a dilation of 3 of a scale factor of 3. So this is a new part. This is something that's not new. Okay. the next thing, this is new. So I'm going to do this in green. I like green. Okay, so if you guys learn that all we do for dilation is multiply each point, the x and y value of each point, by a factor of the scale factor. Our scale factor here is 3. Our k value in here, k value is right there. It's 3. Okay, so our y, or our q double prime, is going to be 0 times 3 is 0. And our -1 times 3 is going to be -3. Okay, so that's that one. Our 1 times 3 is going to be 1. And then our 1 times -3 is going to be negative. Oh, that's wrong. Right, our 1 times 3 is going to be 3. And then our 1 times negative, our -1 times 3 is going to be -3. Okay. And then our s prime is going to be 3 times 2, is going to be 6. And then our -2 for our y value is going to be 2 times -2 times 3 is going to be -6. Finally, for our t prime is going to be 1 times 3 is going to be 3. And then 3 times -3 is going to be -9. So these will be our new coordinates. Well, I'm going to grab my circle here. Circle. I'll start plotting. So I'm going to go, it was 0 and 3, I believe, right? So 0 and -3. So blue, I go 0 and that's this one, 0 and -3. Right, so that one must have been R. Q, that one's Q. Oh yeah, that was the Q one there. That's Q triple prime. So that's for double prime. It's Q double prime. Double prime. Now we're gonna expand R. So it's gonna be 3 -3. So 3. We expanded this out 3 times. 1, 2, 3. And then this is gonna go down 3 times. 1, 2, 3. Which makes sense because this is the same, but it expanded by 3 times because this is length of 1. Now this is length of 3. That checks. All right, so now this is R double prime. All right, so now S, I don't even remember what the point is. I can just be like, oh, okay, well, S was -2, so now it's going to be -6 because it's going to go up by 3. 1. So it was 2, so now it's going to be 6, -6, and now it's going to be 6. Okay, so let's see if I didn't remember the point, but yeah, it's 6 and -6. It's not what, yeah, I put it right there. Okay, so that was S double prime, and then this, what was this? Oh, it must have been T. Label it. This one was T. This was T. T double. So T. Now this is going to be 3 times 3. The y direction is going to be 9. And then 1 times 3 is going to be 9. It's going to be 3. So it's going to be right here. All right. And this is going to be T double prime. Okay. So I'm going to select this guy here. And then I'm going to go ahead and draw. Let's do that on the axis. On the actual line there. That's going to be from here to there. This will be from here to here. So go from here to here. And this will go from here to here. Now you can see that is like a set of, that's like a little baby set of big version of this one. And you can see if I looked at any one of these values, I would see my scale factor, right? I don't even have to do like the actual length of these. I could just see the change in Y, right? Or the change in X for any of these, and I'll see my scale factor, which is pretty neat. Okay, so now we're going to evaluate to see if this transformation set is cumulative. Okay, I don't even have to like replot these to see if they're cumulative. I just need to look at the numbers. I just need to plot the numbers here and then see if these point values match after I'm done doing that, right? So I'm just going to go ahead and do that, right? So I'm going to go ahead and convert these over. I'm going to dilate these just with the algebraic expression. So it's going to be -3. This is going to be -1 or -3. This will be -6. This will be -9, right? And then this will be 0. This will be -3. This will be -6. And this will be -3. Okay. And now if I want to rotate, this would expand this thing like way up into here, right? That would rotate that way up into here, okay? Or that would dilate this guy up into here. Well, in fact, I mean, I could do that, but I don't want to, right? But then if I wanted to rotate this 90 degrees counterclockwise, right? It's going to go bloop from there to there, okay? So then it's going to go, it's actually going to expand it from here to here. Sorry, it's going to expand it from here to here. Because -6 is down in here. Well, it's going to go from the origin into here, so it's actually going to be in here. Sorry about that. Right, so if I'm going to apply -y and x, I'm going to flip my x and my y's, and my negatives are going to turn positive, right? So x values are going to, or my y values are going to become opposite and become my x, right? So this is going to be 0. This is going to become 3. This is going to become 6. This is going to become 3. And then these are all going to become my new y values. -3. This is going to become -3. This will be -6. And this will be -9. Right, now you're just going to bounce these off of these, right? See, this one and this one, these are the same. This one and this one, these are the same. This one and this one, these are the same. And this one and this one, those are the same. And because that these are the same as these, you can say that this is cumulative. This is these two transformations, this transformation series is cumulative, meaning that you can do these transformations in any order and you're going to end up with the same final result with this green polygon quadrilateral in this spot, right? Because lo and behold, it's all right there in that final spot. Okay, so I'm gonna pause this now and we're gonna set up the next one. Okay, so here we have 4 triangles, and you can see that they're all labeled with primes and not primes and stuff like that. So our first one without any primes is this one, right? Let's make that more legible with a red. It'd be a fat red marker. Okay, so this is our first. This is our first original pre-image. Okay, then look, our second one is this one, right? Our third one is this one, and then our fourth one is this one. So we have 3 transformations, right? And then we're gonna try to figure out what the transformation is, right? And then algebraic description for the transformation, and then if it's a dilation, scale factor for it. Maybe we can figure out a point of dilation for it using a couple of different variations of options, and then algebraic description for these things. Okay, so we're just going to go ahead and dive right in. Okay, so first thing we're looking from transformation 1. All right, so for transformation 1, it's going to be T1. From transformation 1 to transformation 2. So this is transformation 1. This is from 1 to 2. Okay, or from our single ones to our primes. All right, so this is pretty obvious here that all I have is, an object that was moved over and down. Okay, it didn't reorient itself. Okay, it's pointing in the same direction. The Z, look at the Z and the X and the Y. They're all pointing in the same direction. Right? It didn't rotate. It didn't flip. It didn't reflect. Right? The orientation is all pointing this way. The Z is pointing that way. The Z is pointing that way. The Y is pointing this way. The Y is pointing that way, and the X is pointing that way on both of these. Right? So it didn't change orientation. Okay? So it's a pretty obvious translation. Translation. Okay, but by how much? It obviously went down and to the right. Down and right. And right. But by how much? Okay, I don't feel like counting all that stuff. Okay, I mean, it could be easy to count, but I want to do it using the delta x and the delta y method. Okay, my delta x is again my final x value. So I'm gonna pick one of these values. Okay, and I'm gonna pick z. Right. So this is gonna be my z prime, my x value of z prime, because this is my final x value after the move, right? Minus my z value of x. That's my initial value of x. Okay, so this is my final minus my initial, and then my delta y is going to be my z prime of y minus my z prime, and my zy, right? So it's my final z value, which is my z prime of y value, and then my initial z value. I could just count it. It's easy just to count it, but I wanted you guys to get used to seeing this, right? Because delta changes are important to recognize. Okay, so my delta x is -2. Negative is my final x value. -2 minus -5. -5. Okay, so -2 minus -5. Bring up my calculator here. -2. No, that's not how I do negatives. Okay, on this thing. Okay, gotta go clear 2 well, no. 2 negative minus 5 negative equals 3. Well, that makes sense. If I look over here, I moved over, you can just count it. 1, 2, 3, but it was in the positive direction. And that's important distinction in direction eyes. You can, if you do it this way, you can't screw up your negative positive as long as you do the math right. Okay, now my z, my final z value is -2. That's weird, I never really noticed that. It's -2. And minus my initial z value, or my initial y value for the point z is negative, or is +3. So this is going to be -2 minus 3 is -5, which means it went down 5 units. So 1, 2, 3, 4, 5 units, which is true. So it went down 5 units. So my transformation is down 5 units and right 3 units. So that passes the common sense check. All right, went down 5 units, +3 or -5, and then right 3 units. That passes the common sense check. So my algebraic expression for that first one is x comma y goes to x plus 3 comma y minus 5. Simple translation. That should be a review. All right. So now I'm going from 2 to 3. So I'm going to change this from 2 to 3. Make it green. Okay. So how do I figure this out? I don't have any real convenient like lengths that I can figure out, right? But do I need a length? I don't necessarily need a length of one of these sides. I really could just figure this out with any of my changes in x or my change in y. That's a trick you can figure out. Okay, so if I just look at my change in, remember my scale factor is going to be equal to anything that I know about my before and my after. Okay, so my before x value, we'll do my before y value. Okay, and we'll go with the z, right? Or we can go with the y. Let's do the y. Okay, my before y, remember it's my scale factor. Anything that I know about my after image or my before, divided by my before. And you notice here that it went from something bigger to something smaller. So you should recognize that my scale factor is going to be a fraction less than 1. Okay, so that's what you should expect to see. All right, so I'm going to do my y value. My before is my y value. I guess I could, yeah, my y value for my y prime value for y. Okay, and so this is my y axis. I'm gonna make the list. So this is my y. Maybe if I do this, my point y value, my point y prime value, which is my initial point. That is the y value of my point y. Okay. Let me move that down a wee scooch. Okay. Divided by the y value of my y double prime. Okay, that's the after y value. Okay, it's not even, this is a distance from what I presume to be my point of origin. So that's how do I verify that that's my point of dilation. So I'm going to verify that real quick just by running some lines through those intersection points and where they come together. That is indeed my point of dilation, right? So I know that that is my point of dilation because that's where all those came together. Okay, so I can say that this is my point of dilation, and the distance, my y value distance, I can use because that is a solid value that is changed between these 2 points, my y value distance. Okay, I could have used the z value distance for y value. I could have used the x value distance for y. I really couldn't use the x value for y because it's still 0. It doesn't really change, right? But the y value was a convenient thing to use here. Okay, so I'm going to say, so my final y value was 3. It's -3. It ultimately doesn't matter if you use, we're talking about distances. So if you're using negative signs, ultimately that doesn't matter. You're not going to have a negative distance unless your point of dilation crosses over from one to another. Then it doesn't matter, right? Because you're going to be doing, because your distance actually here, your distance formula from your point of origin, you're figuring out your distance, and it's 3 minus your initial point is 0, right? So technically that's what we're doing, right? So 3 and then minus a -6, -6. So my scale factor is 1/2. Okay, so therefore my point, my scale factor is 1/2. My point of dilation is the origin, and my algebraic description is going to be x comma y 1/2 x comma 1/2 y. That's my, and then with the 0, 0 center of dilation, point of dilation. They're like the same thing. Okay, so that's that one. All right, so now we're gonna go from 3 to 4. 3 to 4. Okay, so from 3 to 4, we're trying to figure out what happened here. The best way to do this one here is to grab some point that doesn't have the same value as the x and the y, like the same number. Okay, so we're going to use like x prime is our initial, or x double prime. We'll use that one. So x double prime, the x value is 1, and the y value is -2. Okay, now for the x, this is x double prime. This is before the transformation. After the transformation, it has become 2, 1. 2, 1. Is that right? 2, 1. My x triple prime. All right, so I do a simple point comparison. So my x's and my y's flopped. My x's and my y's flopped. My x's stayed the same. So what was initially my x, why did I put x, y? My x's, my x's, my y's flopped. Okay, what was my y changed signs, what was my x stayed the same, right? So this point comparison is the back end of my algebraic expression. And that algebraic expression represents a rotation ,90-degree rotation, 90-degree rotation, and if you remember, it's 90-degree rotation because the x and the y flopped and one of them is negative. If the x is the negative sign is in front of the y, it is a counterclockwise rotation. So this x moved from here 90 degrees to here, right? So about the origin P, right? So if I did a 90-degree angle from here, or from here to here, let me do a little fatter than that. So from here to here, this is a 90-degree angle because it's a 90-degree rotation between this point and this point. This is the initial, this is your final. So it rotated 90 degree that way, and every other point on here did too. Right? So if you can do that one for like this one, let me do a square. So like, yeah, see that worked, right? So if it's a square, it has to be 90 degrees. Let's go like this, face that guy. Yeah, cool. 90-degree rotation of that dude. So that's nifty. And then, you know, if I did my Z point, I'll make my Z point red. Another square. The origin, I think I have to do this thing. It, and that's 90-degree angle too. No, it didn't do that. I think I have to do. I'll just let me do 2 arrows. So I have to be like, no, that's not. Well, you get the idea, right? So that's a 90-degree rotation. The green one, a little arrow, a little green, like that. Yeah, 90-degree rotation that way. So, right. So there you go. That kind of sums everything up. I hope you guys learned something from this one, and let me know if you guys have any questions.